Hello everyone, welcome to Aviation Engineering YouTube channel. Alright, so today I'm going to give you another lesson. So this is regarding EASA Part 66 basic module lessons. So today I'm going to teach about module 15 gas turbine. So this is a series. So this is the first lesson. So in first lesson I'm going to talk about gas turbine fundamentals. Alright. Sorry, gas turbine definitions are the fundamentals. So this series I made these notes from myself, and all the notes according to the syllabus. So I took the syllabus and I make my notes, and I I present for your knowledge. So it means like this is very simple way. So uh, I just included all the things I read into the presentations, and you also can read. So because some people they cannot understand English well, so some people they cannot concentrate on I mean the the things when we talk. Some people they cannot concentrate, so then these people can read this one as same as I you can hear. So that will be a good for you. All right, so maybe if you don't understand, you can translate this one from Google Translate or something. So that's why I made like this. All right, so uh, okay, so let's start this video. And again, I want to tell, don't forget to subscribe Aviation Engineering YouTube channels. Now I have more than 1,500 subscribers, so I think you like this YouTube channel. So thank you very much for the subscribing my YouTube channel, and also share this video with your friends because this channel will be helpful for them also. And also, if you like this video at the end, please hit the like button. All right, so don't skip this video, just see until the end. And if you have any questions or something, just drop down a comment, so I will try to reply you as much as possible. All right, so now we will go to the lesson. All right. Okay. So today is this lesson is EASA module 15 gas turbine. So fundamental, under fundamental. This is lesson number 1. So this is the lesson number 1 is gas turbine definition. Okay. Just remember in this presentation or in this video, I just put my all the things into the as a writing. Okay, so because when I read this one, you also can see the words, right? So then it maybe if you don't understand something, so you can read it, and maybe you can translate it or something like this. So it's better for you. That's why I just do like this, right? All right. So let's go to the gas turbine definitions. All right. Okay, so the content in this lesson is number 1, I'm going to talk about adiabatic definitions, and second, isothermal process, and momentum thrust, pressure thrust, gross thrust, and momentum or intake drag, net thrust, ram ratio, and total head pressure, effect of humidity, compressor efficiency, plenum chamber, and at the end, power turbine. All right. Okay, so let's go to the first one. Yeah, adiabatic definition. All right. So the definition of adiabatic is like expansion or contraction is adiabatic, right? Expansion or contraction is adiabatic when there is no loss or gain of heat by the working fluid. Okay, this is the definition. Okay, I will make it more simpler, right? An adiabatic process is when something happened to a system like gas, so and no heat goes in or out. Okay, so imagine you have a balloon that you squeeze really fast. Okay, imagine you have a balloon, you squeeze really fast, the air inside gets warmer, right? Example, right? If you take a balloon and if you squeeze really fast, and the air inside the balloon is getting warmer, all right? Because you're pressing on it, right? But no heat comes from the outside, right? But no heat comes from the outside. So that is an adiabatic process. Okay, I think for this example, you can get to know, right? Just imagine, right? You press a balloon, right? but inside the balloon, the air is getting warmer, but you cannot feel anything the warm, right? So that is called adiabatic process. So adiabatic process, you can see no heat exchange, just changes happening inside the system. All right, that is called adiabatic definition. All right. So now let's go to the isothermal process. Okay, isothermal process. So, okay, let's see. Imagine you have a balloon filled with air and you keep it warmer room, right? You have a balloon with air and you keep this balloon inside the warm room. So its temperature stays the same, right? Right? So now, when you squeeze the balloon inside the warm room, when you squeeze the balloon, it might get smaller. It means the volume decrease, but because it is in that warm room, right? Because it is in that warm room, the temperature inside the balloon doesn't change at all. Okay, just imagine this one, right? Example, like, you have a balloon, right? And you are in the warm room, right? And you take the balloon and squeeze it, like then the volume decrease, and right, but the I mean because you are inside the warm room and the temperature inside the balloon doesn't change at all. All right. So in an isothermal process, right? In an isothermal process, it's like keeping the temperature of something the same no matter what else happens to it. Okay, you can this one just keep it in base. That's why I highlighted. You can see in an isothermal process, it's like keeping the temperature of something the same no matter what else happened to it. Okay, so like it's kind of like making sure your drink stays cold in a cozy with a cold pack. You want the temperature to stay just right even if you are moving the cozy around or taking ships from your drink. All right, that is called isothermal process. Okay, next one we will go to the momentum thrust. Okay, these definitions actually you will use in the later lessons in the gas turbine engine, right? So we will go step by step. So the momentum thrust. So momentum. Let's go first one. Momentum, right? Okay, imagine you're playing with a toy car. Okay, you can, okay, if you cannot imagine, you just see this is a toy car. Okay, you're playing with it. The toy car is heavy, right? Toy car is heavy, and when you push it, when you push it, it is hard to stop. Why? It's very heavy, right? So that's because it has a momentum, right? So momentum is how much how much force, right? Something has when it is, how much speed. That's why this is called like 0 miles per hour, like how much speed something has when it is moving, right? So when you get a momentum by combining how heavy something is, like the toy car's weight, with how fast it's going, right? So then so I am is like this, right? The momentum is like how heavy something is with and how fast this object is moving, right? So that is called momentum. So let's go to the formula. So formula is momentum equal mass into speed, right? So that is called momentum equal mass into speed. All right, so a big truck, example like a big truck moving slowly and a small car zooming fast can have the same momentum if the truck is much heavy. All right, even the truck is heavier, but it's moving slow. But the car is not heavier, but it's moving fast. So the both both objects have the same momentum, right? So now let's go to the thrust. Okay, thrust. Okay, think of thrust as as the push, right? Thrust is a push that makes things move forward. So when you blow up a balloon, and let it go. For example, if you blow up a balloon and let it go, the air rushing out is like a thrust. It pushes the balloon. Okay, example like this. Okay, you blow the balloon and you let it go, right? So then air inside the balloon is like move backward and then the balloon will move forward, right? So it pushes the balloon forward. So in the rocket or planes, engine create the thrust to make them move. Okay, rockets or planes, right? So that is our subject. So rockets or planes, they create the thrust to make them move. So, okay, let's go to examples. So, like, okay, rockets work by pushing out gases super fast from the back. So, this makes the rockets move forward because of Newton's idea. Okay, we will talk about Newton's later. So Newton's law, okay, we will talk. So for every action, there is an equal and opposite reaction. Okay, that is the Newton's third law. Okay, every action, there is an equal and opposite reaction. So the fast moving gases going out make the rocket move in the other direction. All right. So now if you put them together, right? Example like thrust. Okay, the if you put them together, you might think like momentum and thrust. If you put them together, you might think how rockets use their engines to push out gases quickly, creating a thrust. So, which then makes the rocket move forward. Using the principle of momentum is like a big push that sends the rocket zooming off. All right. Okay. Yeah. Okay. So now let's go to the next one, pressure thrust. All right, pressure thrust. So let's go, first we'll go to the pressure, right? Pressure, this is like how hard you press something. Pressure. Okay, we will take something like, okay, balloon. When we press, that is called, inside the balloon have a high pressure. So that is called, this is high, this is like how hard you press on something. So when you press hard, it's high pressure. When you press lightly, it is called low pressure. All right. So now we'll go to the thrust. This is the push that makes things move. The same thing I described before, right? So this is the push that makes things move. So like when you push a toy car and it goes forward, right? That is called thrust. So now we'll go to the pressure thrust. Imagine, okay, pressure thrust, I will, okay, like imagine you are blowing up a balloon and then let it go. Same thing, right? The air goes out, that rushes of air pushes the balloon in the opposite direction. That's pressure thrust. Okay, that is called pressure thrust. Remember, the high pressure air inside the balloon escapes, making the balloon move the other way. So example, so rockets also use the pressure thrust. Okay, rockets also use the pressure thrust. And inside the rocket engine, gases are squeezed. Okay, we will talk about later. Okay, we will talk about this like compression ratio, something like this. We will talk later. So inside the rocket engine, right, gases are squeezed, like compressed really hard. Okay, when these gases shoot out of the back of the rocket, they push the rocket in the opposite direction, right? It's like a big push that make rocket fly. So another example we'll take, airplane also use pressure thrust in a way. So the shape of their wings makes air move faster on top and slower underneath. So this creates a difference in pressure, which helps lift the airplane up into the sky. All right. Okay. So the pressure thrust, right? Basically, the pressure thrust using the push from high pressure stuff to make things move. Like when you let the air out of balloon or when the rocket engine blast out gases, it's all about that push that make things go. All right. Okay. So let's go to the next one. Gross thrust. Gross thrust. Okay. The same thing. Thrust. This is the push that makes things like rockets, jets, or cars move forward. Is like the engine power to make things go. Thrust. Okay. We discussed before. So now the gross thrust. Imagine you have a rocket engine or a car engine, right? So gross thrust is the full power, right? Imagine you have a rocket engine or car engine, right? So the gross thrust is the full power or maximum push that the engine can give, right? Gross thrust is the full power or maximum push that the engine can give. So it's like saying like the engine can give its biggest push possible, right? So example, think of a rocket ready to launch, right? The gross thrust is the most powerful push it can give to blast off into the space. Okay, so it's like saying like this rocket can zoom away with all its power, right? So another example, you can say now think of the fastest car, right? So the gross thrust is how fast the car can go at its top speed without any obstacle. Okay, I mean gross thrust is how fast the car can go at its top speed without any obstacles. So it's like saying like this car can race at its maximum speed. Okay. So the gross thrust is just the biggest, strongest push an engine can give. Okay. Remember, gross thrust is the biggest, strongest push an engine can give. Like a rocket, mega blast, or car top speed. So just remember, right? So okay, I just give you a basic idea. That's why I included the same thing into the this lesson, and I read it. Okay, while I read it, I will explain something. So that's why I'm telling like you, then you can remember. It's easy for you, right? Okay, and next one, momentum or intake drag. Momentum or intake drag. Okay, so let's go to momentum drag. First one, momentum drag. Okay, so momentum. Earlier we discussed, right? Momentum. This is how hard is to stop something that's moving. Momentum drag. Momentum, this is how hard it is stop something that is moving. So momentum drag, when a fast moving plane, right? When a fast moving plane has to swallow air into the engine. Okay, swallow means a fast moving plane has to take air into the engine. The air's momentum, how fast is moving, make it harder for plane to keep going faster. That is called momentum drag. So example, like imagine running and hitting a wall of air, right? Imagine running and hitting a wall of air. It slow you down, right? That momentum, it means there's a wall of air and you're running, okay? And you hit to the air wall, okay? And what happened? You will be a little bit slower, okay? Right. So that's momentum drag. That is called momentum drag. That momentum drag for the plane is like the air is pushing against, okay? Right. So now the intake drag. Intake, this is where a plane take in air to use for power, okay? So intake drag. Intake drag, if the way the plane takes in air it isn't smoother, it slow the plane down. So it's like breathing through a small straw, right? Breathing through a small straw. It's harder to get enough air. Okay. Example, think of a car trying to drink through a tiny straw. It can get okay like this. Okay, think of a car trying to drink fuel, right, through a tiny straw. So it can't get enough fuel. That's intake drag. It's the air getting in the same way. All right. So now the ram drag. Okay, something else. So momentum drag with relation to the aircraft speed. So ram pressure. This happens when the fast moving plane forces air into the engine. So ram drag is the air momentum due to the plane speed creates pressure that slows down the plane. So example, right? So stick your hand out of the fast moving car. Sometimes when you're in childhood, you do this one, right? So stick your hand out and out of the fast moving car. It gets pushed back, right? When the car is moving forward. When you put out the hand out of the car, then what happened to the hand? It's pushed back, right? So it get pushed back by the air, right? So now imagine the plane engines doing the same thing. It's like the air pushing against the plane. Okay. All right. So in simple terms, so momentum drag is like running into the wall of air. It slows the plane down. And intake drag is like drinking through a small straw. It's harder for the plane to get enough air. And ram drag is the momentum of the air of the fast moving air forcing its way into the engine, slowing the plane down. So in short, I can say momentum drag and intake drags are both like the air giving the plane a big slow hug. Okay, momentum drag and intake drag are both like at the air giving the plane a big slow hug, making it harder for the plane to fly through the sky. All right. Okay. So the next one, the net thrust. Net thrust. Okay, net thrust. Okay, first go the gross thrust. Okay, gross thrust I talked about before. This is the maximum push an engine can give without any lift. So momentum drag. when the fast moving plane has to push it through air, it slows down because of the air momentum. Net thrust is like figuring out how much push it left after the air slows the plane down. Okay, so it's the real push the plane gets after considering how much the air is pushing back. Right? Example, imagine pushing a heavy box across the floor. There's a floor, across the floor, you have to push the heavy box. You're strong, like the engine's power, but the floor might be very rough. Okay, so like the air slowing the plane. Then the net push is how much the box actually move after considering the rough flow. Okay, now I think you got an idea. So in simple terms, gross thrust is the engine full power or maximum push, and momentum drag is like the air giving the plane a slow, heavy hug. And net thrust is the real push the plane gets after subtracting how much the air slowed it down. So it's like a superhero trying to run through the sticky web. Okay, the net push is how fast they can go after the web slows them down. Okay, so for a short note, as a short note, you can just keep it reminder. So net thrust is the actual push a plane gets after considering how much the air slow it down. It's like the real power left to make the plane fly forward. That is called net thrust. Okay, next one, the RAM ratio. RAM ratio. Okay, RAM ratio, engine intake pressure. This is the pressure of the air going into the engine. Engine intake pressure is, this is the pressure of the air going into the engine. So static pressure at the aircraft intake. Static pressure at the aircraft intake. This is the pressure of the air around the aircraft when it is not moving. Static pressure. Remember, static pressure at the aircraft intake means this is the pressure of the air around the aircraft when it's not moving. And RAM ratio, it's like comparing how much extra pressure the engine is getting from the fast moving aircraft. RAM ratio means, remember again, RAM ratio means it's like comparing extra, how much extra pressure the engine is getting from the fast moving aircraft. So example, right? Imagine driving a fast car with the window open. Okay, the air rushing in adds pressure inside the car. The RAM ratio tells us how much more pressure there is compared to when the car is still, right? Okay, so in simple terms, engine intake pressure is the pressure of the air going into the engine. And static pressure as the aircraft intake is the pressure of the still around the aircraft. And RAM ratio is how much extra pressure the engine gets from the fast moving aircraft. So it's like having a fan blowing air into the room. The RAM ratio tell us how much extra speed, like extra wind, the fan is giving to the air in the room. Okay, right. So for a short note, you can say RAM ratio compares how much extra pressure the engine gets from the fast moving aircraft. That is called RAM ratio. So it's like the boost the engine gets from speed. All right. So the next one, total head pressure. Total head pressure. Okay. Total head pressure, the first one, the total pressure of supersonic air. Total pressure of supersonic air. So this is the pressure of the air when it is moving super fast. Okay. This is the pressure of the air when it's moving super fast. So that is called supersonic. Bringing air into the rest ahead of the intake. So this means slowing down the super fast air before it goes into the engine. Right, so now the total head pressure, total head pressure. So it's like making the super fast air stop. Okay, it's like making the super fast air stop and measuring the pressure. So example, imagine a fast moving river suddenly hit a wall. Fast moving river suddenly hit a wall. The water plies up backwards, right? Creating extra pressure at that spot. So total head pressure is like measuring the extra pressure when the air stops suddenly. Okay, total head pressure is like measuring the extra pressure when the air stops suddenly. So in simple terms, I can say total pressure of supersonic air is the pressure of air when it is flying really fast, and bringing air to rest ahead of the intake is means making the fast air slow down before going into the engine. The total head pressure is the extra pressure created when the fast air stops suddenly. Okay. All right. So for a short note, you can say total head pressure measures the extra pressure created when the super fast air is brought to a sudden stop. It's like the sudden brake effect on the air. All right. Okay. Now the effect of humidity. Effect of humidity. Okay. Effect of humidity. Let's go first one. Humidia. What is humidia? Humid air, this is air that has a lot of water vapor. Humid air means this air include lot of water vapor. So less dense. Water vapor makes the air less packed together. Okay. Water vapor makes the air less packed together. So it's not as heavy or dense. Okay. Less dense. Water vapor makes the air less packed together, so it's not as heavy or dense. So less weight of air enter into the engine. Less weight of air enter into the engine. When the air is less dense, when the air is less dense, it means there is a less stuff. It means less weight going into the engine. It means less air, less stuff going into the engine. So example, imagine trying to fill a bucket with a cotton candy instead of rocks. The bucket won't weigh as much because cotton candy is light and fluffy, like humid air. All right. So in simple terms, humid air is air with a lot of water vapor, and less dense means this means the air is lighter and not as heavier. So less weight of air entering the engine. When the air is in lighter, it means there is not as much stuff going into the engine to create a thrust. Okay, so for a short note, you remember effect of humidity. Humid air is lighter and less dense. Humid air is lighter and less dense, so there's less weight of air going into the engine. This means less thrust is created because there's not much as push from the air. If there's high dense, then high thrust. Less dense, less thrust. Okay. Right. Okay, let's go to the next one, compressor efficiency. Compressor efficiency. Okay, let's go first one, temperature rise. So this is how much the air temperature increases as it goes through the compressor. Okay, we will talk about this thing later. Okay, this is like a definition. So this is how much the air temperature increases as it goes through the compressor. So efficiency is this tells us how well the compressor doing its job. Okay, efficiency is how well the compressor is doing its job. If the temperature rise is too big, it might means the compressor is not working efficiently, right? It means if the temperature is rise very high, it means the compressor is not working efficiently, right? Example, right? Imagine you are blowing up a balloon. If your cheeks get really hot because you are blowing so hard, it might mean you are not blowing efficiently. All right. Okay. Okay. In simple terms, the same thing. I just put it right. You can read. And for a short note, compressor efficiency. This tells us how well the compressor is working. Right. If there's air get really hot as it goes through, the compressor might not be very efficient. So it's like checking if pump gets too hot while filling water bottle. Okay. It might not be working its best. All right. Okay. Next one, plenum chamber. Plenum chamber. So plenum chamber. Okay, first one, chamber in an air intake system. Chamber in an air intake system. So it's like a special room. Plenum chamber is like a special room or space in the air intake system of a vehicle. Flows, okay? The plenum chamber helps to make this flow smooth and steady, right? So constant air supply means by smoothing out these air waves. By smoothing out these air waves, the plenum chamber makes sure the engine gets a steady, constant flow of air. Okay. All right. So example, think of water tank with a tap. So sometimes the water pressure can be uneven, water pressure can be different, so causing splashes or sputters. The tank helps to even out the water flow so you get a steady stream from the tap. Okay, so in simple terms, I just tell like plenum chamber is like a special room in the air intake system and smooth out pulsation. It helps to make the airflow steady and smooth and constant air supply. By doing this, it ensures the engine always gets a steady amount of air to work properly. It's like having a big jug of water that fills up slowly and evenly, making sure your glass never runs dry. Alright. Okay, so for a short note, a plenum chamber, a short note for a plenum chamber is special room in the air intake system that makes sure the engine gets steady. Even flow of air is like a buffer that smooth out any bumps in the airflow. All right. Okay, the next one is power turbine. Okay, right. The power turbine. First one we'll talk free turbine. It's like a turbine that can spin independently. Okay, it's like a turbine that can spin independently, not connected to anything. That is called free turbine. So not connected to the compressor. So this turbine isn't linked or attached to the compressor, the part that squeeze the air. Compressor means the part that squeeze the air, compress the air. Example, imagine a pinwheel spinning freely in the wind. It moves on its own without being connected to anything else. That is called free turbine. Okay, so in simple terms, as I said before, I just included for you to understand, a power turbine is like a spinning wheel that moves on its own, and free turbine is not stuck or connected to the part that squeeze air and not connected or compressor. This turbine spins separately and doesn't rely on the compressor to move. So it's like a pinwheel spinning freely without being tied to anything. For a short note, power turbine, spinning wheel as power turbine is spinning wheel in the engine that moves independently, not linked to the air squeeze part, is like a free spinning wheel. All right. Okay, that is the end of the first lesson of gas turbine, module 15. All right, so I think you got a good knowledge about this one. Okay, this is a series, so you can watch this one first, and I will upload more every lessons, right? And I want to tell these all notes made from me, and I take the syllabus. I take the syllabus and I break it into the some parts, and then I made and presentations, and then I will give for you because these notes very easy for you to understand. So I think you got a good knowledge. So waiting for the other lesson. So the next lesson I'm going to describe about the physics overview regarding the gas turbine, right? Physics overview. So I will describe Boyle's law, Charles' law like this. All right. So thank you for participating in this lesson, and thank you for watching this video until end of this video. And don't forget to subscribe to Aviation Engineering YouTube channel, and don't forget to share these videos with your friends, relatives, anyone. Okay, and especially with the students who preparing to write the gas turbine engine. Yeah, that's all. And if you like this video, please hit the like button. Okay, so see you on next video. See you on another. Sorry, see you on next video. Have a great day for all of you. Thank you. Bye bye.